So a lot of the times you're going to see a chart in a textbook that looks a little something like this. One of the things that I want you to keep in mind when you're interpreting this chart is we know that delta G naught is equal to delta H naught minus T delta S naught. So we can come up with different circumstances where we look at delta G, where the sign of delta G, based on the sign of delta H naught and the sign of delta S naught. If we look at the more standard examples, if our delta S is positive and our delta H is negative, the sign of our delta G, if we put a negative sign in here for the delta H and a positive for the delta S, this is going to be negative, and this is going to be, or our delta G naught is going to be negative at all temperatures. So that means we're going to be spontaneous at all temperatures. The reverse of this situation would be if we have a positive value for delta H and a negative value for delta S, our delta G value is going to be positive. And we can say that delta G naught is going to be positive at all temperatures. So this particular reaction is going to be non-spontaneous. But in the case that we just looked at before, we had a value that was positive for delta H, and it also had a positive value for delta S. In this particular case, in some instances, we can have a negative delta G, and in some instances, we have a positive delta G. Like we said earlier, if we increase the temperature, we can make this more negative. So our negative delta G is going to happen at high temperatures, and our positive delta G is going to happen at low temperatures. So in this particular case, when we have a positive value for delta H and delta S, it's going to be spontaneous at high temperatures and non-spontaneous at low temperatures. And that high or low is kind of a generalized statement. So in that case, we actually have to do a calculation to figure out at which temperature we would observe a spontaneous process. Same thing happens if we have a negative value for delta H and a negative value for delta S, except the temperature part is reversed. If we have negative values for delta H and delta S, our delta G is going to be positive at high temperatures, and it's going to be negative at low temperatures. So in this case, we're going to be spontaneous at low temp and non-spontaneous at high temperatures. You definitely need to know all the information on this particular chart. I would caution you to just memorize this thing. What I would suggest is take this particular equation right here, make sure you know this equation, and use this equation to generate the chart that you'll see here. And this chart is listed in practically every textbook that talks about this stuff. And you will see this pretty much everywhere. You're going to need to know how to manipulate this particular chart, and typically it'll ask you, and I'll give you some examples that we'll go over on Wednesday that correspond to this particular chart. Okay? So we're going to pick up on Wednesday with some examples of this, and we'll be looking at delta G at non-standard conditions.